All right, fellas on YouTube, for everybody following the Honda Kubota RADtech slash Walker, maybe John Deere snowblower rebuild modification thread, happy to report that basically all the fabrication work required for the impeller, the chute, rotation, the new impeller housing, the shaft, and the hydraulic motor system are all done. We're waiting for basically just some time to clean everything up, soak it down with phosphoric acid, clean it with maroon Scotch-Brite, let it dry, and then give it a coat of paint. I think I'll paint it my favorite color, no wash gray. It always seems to look good. Both my cars are no wash gray, as I like to call it. And that white stuff right there is just a bit of phosphoric acid cleaning up some of the mill scale, which is a great way to remove mill scale prior to paint. And I've got another trick up my sleeve for painting this stuff with one component paint. Maybe I'll show you guys that a little later after it's all painted up. So there's the impeller all finished up. I had a bit of warpage on the back side of it, and I put 4 or 5 strategic, very hot welds on the back side of the impeller to pull out some of the warpage. Despite my best efforts to clamp it down to the table, they were still putting a lot of heat in a relatively thin piece of sheet metal, 1/8 of an inch, cold rolled or hot rolled steel per se, so you're going to get some warpage. Anyway, I managed to take out pretty much all the significant warpage with 4 strategic welds. I actually burned through right there and cleaned that up. 4 strategic welds on the back side of the impeller housing. You can see we got our blade lead installed, which it is farther along. If you draw a line from the center of the rotational axis to the exterior, that's the point right there. So snow will naturally fly off from centrifugal force, but it will also fly backwards. So that gives it a little bit of a head start exiting the chute. So I had to do just a little bit of touch-ups. Here, there's a couple of unground welds on the inside of the housing, which were contacting the fan blades here. And as you can see, I left myself 1/100,000th of an inch gap between the outer diameter of the backside of the impeller and the blade itself. The other thing I did here too was I gave myself that gap because as much as I tried to, that housing is not parallel to the front, and everything moves when you weld it, especially on some of the super thin, relatively super thin sheet metal here in the housing, and it didn't quite line up 100%. So I mean, it's still pretty damn close, and much closer than I think you'd find anything OEM. And the other point of this was to have a flat back of the impeller so that you would have a uniform surface in which snow would be, I guess, pushed into the housing from the augers. So I did get a chance to try this out here on Monday or Tuesday. I think it was Tuesday because I was still working on it. And unfortunately, I put on the augers out of sequence there. So basically, the one on the right is supposed to be on the left. And what it was doing is pushing snow out from the middle of the snowblower as opposed to from the inside inwards into the impeller housing. But it still threw snow like very far. And I'm pretty confident that everything's going to be just Ricky Tick. I might upgrade the sprocket diameter to increase the impeller speed, as everything here is much more substantial, much more heavy duty, and much more rigid, that's for sure. So we could probably take a little bit more speed on that impeller. Didn't show much of the machine work here to make these retainers. I have 2 installed because you need to have 2, or you can't put this on with more than 2 installed. So these follow the radius of that ring there, and they clamp down. As you can see, I got a little bit of rubbing, so we'll have to clean that quadrant up. And again, that thing warped as we welded it, so we'd expect it to wear in over time. What I do have some real more lapping compound. I could probably just slather that on and then rotate this thing to no end until it all bedded in, and then clean it up and then reapply grease or whatever heavy lubricant you wanted to apply there. That would be one way of doing it, or I could just locally sand it down, but you can see that's our spot where we have some contact. There's the stop, the chute rotation stop. I just welded on some 1/2 inch stock, and it is I guess held captive or limited by those two pegs right there that I installed. You can see that a little bit better. And what I'll do is I'll take some hose material and press it on over there, and maybe just put it on with a bit of silicone to keep it snug, and then that way it'll collide and have a little bit of cushion for us. Now what I don't know is if the chain will be strong enough to withstand the torque that I supply, because basically we're going to ask the chain to take all of the load, so we do anticipate the chain to stretch. So as soon as that pin collides against the stop at full force, it's just a guessing game to whether that chain's going to stretch or it's going to break. I have no idea. Again, not a very strong hydraulic system on the GF 1800. It's only 600 psi, but we'll see and make adjustments if required. I might have to reduce the pressure out to that motor there, but it works really good. The speed is pretty sweet. You can go left or right in basically less than a second. That is a 2.2 cubic inch motor. Princess Auto had them on sale for like $110 or something stupid from 200. So I picked that up. It was basically the smallest displacement motor I could get, which I figured would work. So if you wanted to go even smaller, you're gonna speed it up quite a bit more, but that 2.2 cubic inches was actually a really good fit for my GF 1800 and its hydraulics. There's the pins for the hydraulic motor adjustment. One at pivots, the other one is the relief to adjust the chain tension, and I just welded on that peg right there with a thread in it. And I'm gonna make a cover to cover up the chain just so it doesn't get all clogged up with snow and ice, and have an opportunity to get launched off there. All right, so there's all the fabrication work basically complete. And it's just a matter of cleaning it all up, reassembling it, switching the augers around so that it pulls snow inwards, and putting it all back together and hope for another snowfall. So I got paint to do, assembly, and then we can consider this part of the project complete. What I do need to do is make a new scraper bar at the bottom. As you can see, it's pretty banged up. It no longer follows that 45-degree or whatever angle that is supposed to be there. It no longer follows that. So what I'm going to do is I'm just going to weld on a plate of 1x3 or not 1x3, but 1/8 of an inch by 4 inches, and by the width of this thing. And then we'll use that. And I may make a flat bottom, put some UHMW under there, or simply hard face it. So anyway, that's what we got going on. This is basically the end of the fabrication work. I hope anybody watching this has helped out, and I really hope to bring you guys a video of what it looks like when we get into some snow. And the next forecast is maybe in about 10 days for another 10 to 15 centimeters. So let's hope for that even sooner, and let's hope I get it all together without drama and get a video for you guys there. All right, thanks again for watching.